This set of notes deals with igneous structures formed beneath the surface and includes various types of igneous intrusions, or plutons, like batholiths, stocks, sills, dikes, diatremes, etc., which represent ancient subterranean magma bodies. Shown here are light-colored intrusions of the Cottonwood pegmatite complex, exposed between Cottonwood Creek and Vishnu Creek on the Colorado River in the Grand Canyon. These rocks are Paleo-Proterozoic in age, specifically between 1685 and 1680 million years old. So they represent magma bodies that intruded over 1.5 billion years ago in the Grand Canyon. Unseen beneath any volcano is a magma body of some sort. These elusive, intrusive structures take many forms, and only after cooling, crystallization, uplift, and erosion are these features exposed at the surface so that they may be studied directly. The word pluton is a generic term that describes any intrusive igneous body that may take many different forms. Plutons can be massive, like batholiths, or tiny, like some dikes and sills. Their shapes can range from irregular blobs to sheet-like and tabular, or even balloon-shaped, and we call these diapirs, just like you'd see in any magma lamp. Remember, in Dr. Bob's class, we never call that a lava lamp. Let's start by talking about the larger intrusive bodies, batholiths and stocks. Examples would be the Sierra Nevada batholith in California and peninsular ranges, the Idaho batholith, and others, which essentially represent the magma chamber complexes for volcanic mountain ranges that have long since been eroded away. So, batholiths are the largest plutons, covering at least 100 square kilometers in area. Batholiths are typically an aggregate of smaller, related plutons called stocks that may or may not have all been molten at the same time. Probably not. Large volumes of magma typically take thousands to hundreds of thousands of years to crystallize. Indeed, the age range of large batholithic complexes like the Sierra Nevada batholith can span millions of years. Large batholiths are typically felsic to intermediate in composition. Half Dome is a glacially eroded granitic monolith that is part of the Sierra Nevada batholith. Pretty much everything you see in that picture was once part of a magma chamber deep within the earth. And farther south, to the east of San Diego, are the Jacumba Mountains, whose granitic terrain is part of the Coast Range batholith. Again, just about everything you see there was part of a subterranean magma chamber complex. Let's check out the Sierra Nevada and peninsular batholiths. The Sierra Nevada batholith is well exposed in Yosemite National Park in California. Half Dome is a granitic monolith that rises over 4,700 feet above the valley floor and stands sentinel to the entrance to the park. Half Dome is composed of granites of the Cretaceous Tuolumne intrusive suite, which underlies much of the park. Just about everything you see in this landscape represents rock originally formed deep within the earth in magma chambers and has been exposed by millions of years of uplift and erosion. The Jacumba Mountains Wilderness is located in the Coast Range of Southern California, east of San Diego. This is a terrain composed mostly of Mesozoic granitic rocks, similar to the ones at Yosemite. Here, Interstate 8 follows Meyer Creek as it cuts the Inkapa Gorge. And farther south, the Valley of the Moon is nestled into the light-colored granitic landscape right along the U.S.-Mexico border. The rocks of much of Camelback Mountain in Phoenix represent the exposed part of a larger batholith that is Paleoproterozoic to Mesoproterozoic in age, anywhere between 1700 and 1400 million. Camelback Mountain is a prominent landmark in the Phoenix area. Here's the view looking more or less towards the northeast. Camelback Mountain is one of many fault block remnants exposed in this part of the valley, and this mountain has a notable likeness to a kneeling camel. On the west side, the head of the camel is composed of Middle Tertiary sedimentary rock, but the hump and the rump are made up of Proterozoic granitic rocks. The Echo Canyon Trail ascends to the summit from the west, whereas the Cholla Trail comes up from the east. Similar granitic rocks are exposed in nearby areas, including at Papago Buttes and the Desert Botanical Gardens to the south. Rocks at these separate outcrops may represent a larger batholithic structure that has been modified by faulting and erosion and then covered by younger superficial sediments. The area from the northern McDowell Mountains to Cave Creek represent another batholith in the Phoenix area, and this one is about the same age as the one at Camelback Mountain. It's Mesoproterozoic, about 1400 million years old. Much of the northern McDowell Mountains and North Scottsdale area, located just northeast of Phoenix, is underlain by eroded Mesoproterozoic granitic rocks. Small hills and buttes, like these, are the only bedrock remnants of this batholith. Farther north, in the Carefree and Cave Creek area, the western boundary of this batholith is exposed at Black Mountain. The darker terrain is composed of older Paleoproterozoic metamorphic rock, about 1700 million years old. Sills are common sheet-like intrusions that follow the layering in the surrounding country rock. Sills are usually emplaced at relatively shallow depths, and that's because the magma is actually forcing its way along a fracture, and it's pushing outward on the surrounding rock. And at shallow depths, it can do this because the magma pressure is greater than the pressure of the surrounding rock pushing in to keep the crack closed. At deeper levels, the pressure is greater and it basically keeps that seam closed. So magmas actually can propagate and form their own cracks and intrude along those cracks, and sills are the ones that are following the existing layering in the rock. These plutons typically range in size from tens of meters thick to a few centimeters. The dark-colored sill shown here along the Colorado River is only about a meter thick. Notable sills are located in the Transantarctic Mountains of Antarctica. Here we see a dark-colored mafic sill intruding lighter-colored layered rocks. Along the Rio Grande River in Texas, this mafic sill is in Big Bend National Park. And a classic sill is exposed along the west bank of the Hudson River in New York. This is the Palisade sill. The Palisade sill forms prominent cliffs on the west side of the Hudson River in New York. The sill is mostly composed of resistant diabase that intruded as sills about 200 million years ago during the earliest Jurassic period. Dinosaurs would have been roaming the surface at that time. The vertical fractures are known as columnar joints and form as the magma cooled at a shallow level and developed perpendicular to the top and bottom of the sill. Looking south here towards the George Washington Bridge and New York City beyond. Dikes are also common sheet-like intrusions, but differ from sills in that they cross-cut the layering in the surrounding country rock. Dikes are commonly associated with sills and other plutons, and they are usually placed at rather shallow depths. These plutons typically range in size from meters thick to just a few centimeters, like these exposed along Wolf Creek in central Arizona. A famous landmark is Shiprock, located near Four Corners in northwestern New Mexico. Shiprock is where several sets of dikes radiate away from a central volcanic neck. Known to the Navajo as the Winged Rock, Shiprock is located in northwestern New Mexico near Four Corners. 3 major dikes radiate away from the central volcanic neck, and these dikes range in length from 3 to 9 kilometers. A total of 6 dikes have been recognized altogether. These are composed of minette, a rather uncommon rock type, the dike rock is more resistant to weathering than the surrounding Mancus Shale. Thus, over time, differential weathering and erosion have caused the more resistant dike rock to stand out in relief relative to the softer surrounding Mancus Shale. The Spanish Peaks area of southeastern Colorado is also famous for its large dikes that form giant walls that trend across the landscape. Let's head to southeast Colorado, to Spanish Peaks country, where there are at least 500 dikes that represent magmatic activity that occurred from 21 to 27 million years ago. This felsic dike is one that radiates from the West Spanish Peak stock. And is one of many similar, typically felsic dikes. These dikes range up to 100 feet or so in width and are as long as 14 miles in length and can stand as high as 100 feet above their surroundings. Here are two small dark-colored mafic dikes intruding lighter-colored country rock at South Mountain in the Phoenix area. This is a road cut in Connecticut showing lighter-colored felsic dikes. And this is along the Colorado River in the Grand Canyon at Hance Rapid, where a large mafic dike is cross-cutting reddish-colored sedimentary rocks. Let's go to Hance Rapids along the Colorado River in the Grand Canyon. And at the head of the rapids, this prominent mafic dike is exposed on river right. And while this specific dike has not been dated, it likely correlates with Mesoproterozoic Cardenas basalt exposed just to the east, which has a date of 1104 MA. Here, this dike intrudes the 1187 to 1167 Hacketai Shale, and it likely correlates with the prominent diabase sill exposed just downstream. So, what happens if a dike makes it to the surface? Well, this fissure vent at Kilauea represents the portion of a dike that has breached the surface and is erupting magma, now lava. If the eruption is active along most of the length of the fissure, we can call it a curtain of fire. And typically, the eruption will focus down onto a certain segment or spot, and you will get a large lava jet called a fire fountain. A volcanic neck, or volcanic plug, is a resistant erosional remnant of a volcanic pipe where the volcano and softer surrounding rock has been eroded away. A diatreme is a breccia-filled or debris-filled volcanic pipe formed by an explosive eruption. These typically have a conical subsurface shape with a low, broad crater rim at the surface. Erosion over time exposes deeper levels of the pipe, which may eventually form a volcanic neck, if it is made of resistant rock. Agathola Peak near Monument Valley, Arizona, is an example of a diatreme that forms a volcanic neck. Located in northeastern Arizona, just south of Monument Valley, is Agathola Peak, a prominent volcanic neck of the Navajo volcanic field. Similar to the more famous Shiprock to the east, this eroded volcanic pipe, or diatreme, once fed an explosive Mar-type volcano about 25 million years ago that is since entirely eroded away. Agathola Peak includes tough breccia, wall rock breccia, and thin minette dikes. It rises 1,500 feet above the surrounding plain. Look for Agathola Peak when you're driving north from Kayenta towards Monument Valley. Of course, northwestern New Mexico's Shiprock is a world-class example of a diatreme that forms a volcanic neck. Millions of years of erosion has removed the original volcano and surrounding country rock and lowered the original ground surface to where it is today. This has exposed the deeper levels of the volcanic system, including the main conduit and several large radiating dikes. It's kind of cool to think about what we're looking at here. Shiprock itself is a volcanic pipe, and so there's a magma chamber at a deeper level, and the magma's coming up and through the pipe into the volcano and onto the surface. But these dikes represent fissures that are radiating away from that central conduit in different directions. And so not all the magma that is coming from the magma chamber comes up that main conduit. Some of it is shunted off to these fractures where it is propagating away in different directions from the main conduit. Shiprock is a volcanic neck and set of dikes that rises 1,583 feet above the surrounding sedimentary plain, which is here underlain mostly by the late Cretaceous Mancus Shale. This intrusion has a potassium-argon age of 30.6 million and is estimated to have been in place between 750 to 1,000 meters depth below the original surface. And it represents the subvolcanic conduit that connected to a volcano on the surface that likely formed as a result, now totally eroded away. This volcanic neck is classified as a diatreme and is composed of tough breccia and wall rock breccia cut by thin intrusions of minette, similar in composition to the large dikes. Several smaller plugs are also present. Diatremes and other volcanic features are very common in the Four Corners area in what is known as the Navajo volcanic field. So here is the Four Corners, and this shows the distribution of various volcanic vents, including Agathla Peak, Church Rock, Shiprock, and others. Intrusive features are also common in the Hopi Buttes area, in what is called the Hopi Buttes volcanic field. These vents are somewhat younger than the ones in the Navajo volcanic field, but include many of the same volcanic and subvolcanic features. Intrusions often have important economic significance, as they can form different types of ore deposits that tend to be enriched in valuable elements and minerals. In a typical magmatic environment, magmas and mineral-rich fluids, or hydrothermal fluids, move through the fractures surrounding the igneous body. These magmas and hydrothermal fluids are commonly rich in elements like gold, silver, copper, etc. And as they cool, ore minerals crystallize. If this occurs throughout a large volume of rock surrounding the igneous body, we call this a disseminated ore deposit. If the ore minerals crystallize along a fracture, we call that a vein deposit. Each of these would be mined in a different way. The disseminated ore deposits typically in an open pit fashion, versus the vein deposit would be an underground mine approach. Water-rich magma and hydrothermal fluids injected into these fractures form pegmatite dikes. They can have very large crystals and high abundances of trace elements, like rare earth elements. Pegmatite dikes are ore deposits that are extracted using underground mining methods, where the mine will be located right along the vein deposit, as opposed to an open pit method, which is mining a much larger volume of rock, which would be more appropriate for a disseminated ore deposit. Kimberlite pipes are a type of diatreme and are conduits for magmas that originate deep within the earth. Kimberlite pipes are important because they are the source of most of the world's natural diamonds. These deposits exist all around the world, with many in South Africa, Australia, Canada, Siberia, and elsewhere. Well, that's all for now. Till next time.